Welcome, everyone. So wonderful to have you here. My name is Courtney Clark, and I serve as the Program Director of Everywhere She Maps for the YouthMappers Network. I'll tell you more about Everywhere She Maps in just a moment, but first, I'd love to introduce our fantastic guest speaker who's joining us today to talk about interactive mapping and geospatial analysis. We're so lucky to have Dr. Qiusheng Wu. He's an assistant professor of geography at the University of Tennessee in Knoxville. His research interests include geographic information science, remote sensing, and environmental modeling. And specifically, he's really interested in applying geospatial big data, machine learning, and cloud computing, such as the Google Earth Engine, to study environmental change, especially surface water and wetland inundation dynamics. He's also a very strong advocate of open science and reproducible research, and we're incredibly lucky to have him here today. He'll start presenting in just a moment, but for those of you who aren't familiar with Everywhere She Maps, I want to give a brief introduction. So this is a program which is part of the YouthMappers network that is designed to increase women's participation and support women mappers within YouthMappers, but also within the geography industry more broadly. Critical features and attributes that are most relevant to women are missing from maps as a result of their underrepresentation in the geospatial field. So we designed Everywhere She Maps, which launched about a year ago, to help women have better access to careers and professional development opportunities within industries that utilize geospatial technologies. We really aim to strengthen the inclusiveness of the geospatial community. And we're focused on helping women build their technical capacity, enhance their professional and networking skills, and contribute to mapping projects that add data that's relevant to women's needs. We do this through 4 core activities. The first is professional and career development, and that's what this session is part of today. So we're offering technical and soft skills training to students within our network to help them advance within their careers and their job search process. And we also have an internship match program where we work with partner organizations to source internship opportunities for YouthMappers students. We also have 8 amazing women who serve as regional ambassadors. They are really our boots on the ground, voices in the field who are working directly with YouthMappers chapter to increase women's participation. We host a variety of mapping campaigns, largely by contributing to OpenStreetMap that focus on data that's particularly relevant to women and girls. And then COVID permitting, next year, we're hoping to launch our Women in Technology Leadership Fellowship. We have a variety of sessions forthcoming that you might be interested in. So there's a link on the screen and we'll share it in the chat to our Eventbrite, where you can find all of our upcoming online sessions. And these span a wide range of topics from internship and job search skills to leadership and technical skills. And we'll be hosting the sessions in this particular series through January of 2022. So with that, I will pass things over to Dr. Wu, and thank you so much for coming.
Okay, can you hear me, Connie?
Yes.
Okay, let me share my screen. Can you see my screen now?
Yes, that's perfect.
Okay, give me 1 second here. All right, thank you everyone for attending, and thank you Connie for organizing this workshop and setting up the event. It's a lot of work, but I'm really excited to present some of the work that I have been doing during the last couple months, and hopefully you will learn something new that you can potentially use in your research or in your projects. And so I sent the link, some of the links in the Zoom chat. You can click the link to get access to the slides. You can also get access to the source code, and I will also demonstrate how to use the interactive web app. So you can also scan the QR code on the PowerPoint slides here to get access to the slides, or you can go to the URL gshub.org/ym. So, and the topic today is interactive mapping and geospatial analysis with Leafmap and Jupyter. So we're going to introduce that shortly. Here is the outline, and I will first give a brief introduction to the Leafmap package, and I will show you some of the key features, give you some like big picture of what kind of things you can do with Leafmap, and then I will demonstrate the interactive web app, how you can utilize that, and show you some additional resources. Then we spend most of the time to go through some notebook examples, basically hands-on. You can follow me, you can execute, and to create interactive map and do geospatial analysis interactively. Hopefully, at the end, we have time for question and answers. Okay, so first, let me briefly introduce Leafmap, and it's an open source Python package for interactive mapping and geospatial analysis with minimal coding in a Jupyter environment. So I want to highlight here minimal coding. So basically, you can just like write a few lines code. You can create some fancy, nice looking interactive map, and you can do a bunch of geospatial analysis even without writing any line of code. Everything runs directly within a browser. So you don't need to install a huge package on your computer. Just open a browser and then you are good to go. So you can do that on your tablet, on your iPhone, on your iPad, whatever laptop or computer they're using. And you can go to the link here. The source code is hosted on GitHub. So you can go to the GitHub URL to take a look. And I started this project in May 2021. So the project right now is only 6 months, and it has almost close to 1,000 stars on GitHub. So you're welcome to check out the source code. Everything is open and open source and open access. I provide a lot of tutorials and examples, and you're welcome to check out the GitHub if you also want to contribute to the package. It is a Python package, so you can install using PyPI or Conda. I also have a video here showing how to install. And today we're just going to use the browser, but you're welcome to set this up on your computer later if you want to do that. And so Leafmap supports Google Colab and also Jupyter. In the past, Google Colab does not support IPyLeaflet. So let me maybe take one step back, give you a kind of a quick overview what Leafmap it is, because there are so many open source mapping library right now available. And so Leafmap basically trying to make things easier for you. Just think about when you need to write something. For example, you can open the Microsoft Word document on your computer. You can install it. You can use the Google document. You can use Microsoft Office 365, or you can use any other web platform to write something. But keep that in mind, they all have different functionality. They have different user interfaces. You basically have to learn multiple software packages to do something. So Leafmap kind of use this idea, just integrate, build on top of multiple mapping library, and provide a simplified API that you can just use the same line of code to create maps. All you need just to switch which mapping library you want. And it has a lot of interactive component allow you to do things without having to write any line of code. So makes things much easier, especially for beginners, those who are not very skillful in coding. So I'm sure you will be able to follow through, because everything I'm going to go through here today is reproducible. So as long as you have internet access, you will be able to do exactly what I'm going to show you here shortly in this workshop. And so you can open using Google Colab. And the second one here is called Jupyter. Jupyter is, if you have not used this before, it's just like a coding environment, allow you to execute, for example, Python code, but you don't have to install anything on your computer. We can use some online version. Just think about you use Google document to write a report. You can use Jupyter to write source code, Python or other languages, and then you can execute. So I'm going to show you some hands-on examples later. But for now, let's get into the documentation. So Leafmap has a website, leafmap.org. You can go to the website to take a look. So it has very comprehensive documentation. Also the API reference. You can look at the source code of every individual function. I also developed a lot of notebook examples. So you can just open the notebook and then run the code interactively. I also want to show you some examples later, but I also published a short paper describing the package. You're welcome to look at the paper and cite it if you find it useful in your research. So next, I'm going to quickly go through some of the examples, what kind of things you can do with Leafmap. So just some of the features, not all of them. So, but just to give you a quick overview. So here, for example, we can change the base map interactively without coding. Again, everything runs within the browser. You don't need to install anything on your computer. And once you create a map, you can change the base map interactively. So there are thousands of base map available. Besides changing the base map interactively, you can also search base map. So you can select from the drop-down list, or you can just do a quick search. For example, you can click the button and then you can search any keywords, because there are so many open web services on the internet. And here we can use the so-called XYZ services or QMS. Then you can just basically search and then one click to load the data onto the map. You don't have to download any data. So you can utilize this to overlay as basically as the base map to be used in your project. And there are over 1,000 base map available. So you can just one click, for example, Google Map or any other Azure base map, anything that's published publicly available, you can use that. You can also, like this, create a base map gallery. So for example, if you want to see to pick up a base map for your project, and it might be a bit tedious to go through each individual, so you can just create, for example, this one has 100 base maps, so it's all linked together. If you pan or zoom to one of the base map, it will automatically link to all of those. So all the example I'm showing here, we're going to get hands-on later, but just going to give you some overview. And you can also create 3D maps. For example, if you have a CSV file with latitude and longitude, for example, any location data, you can add that to the map directly. And you can create this kind of a 3D maps. You can customize the color, you can customize the symbology. Everything is like customizable. So you can do that easily using Leafmap. So this is built on top of a Capital GL, but we also have PyTex. So there are a couple, right now, in total 5 protein backend you can choose from. And you can use PyTex, you can use a Leafmap, you can use Folium. Again, we're going to get into this later. And you can also open data from the internet. So for example, if you have a CSV hosted somewhere, or if you have some data on your local computer, you can directly open and then load it on the map without having to write any line of code. And so Shapefile, GeoJSON, or any GeoPandas supported vector data format, you'll be able to add to the map, and then you can just hover your mouse, you'll be able to see the attributes associated with the selected feature. You can also just load data directly from the internet, and then you can select what kind of pop-up attribute. For example, in this case, it's cities, right? Marker cluster. You can click on the map, then you'll be able to see all the attributes for each point feature class. And yeah, similar to the one I showed you earlier, right? You can click on the map, just no coding or just 1 or 2 lines of code. You can create this map, this kind of map. You can also download data from the OpenStreetMap, right? OpenStreetMap is a large vector database, open access. So you can use the base map, but if you want to download vector data, the original data, you can use Leafmap to download it. Just 1 line of code, you can download the vector data as a GeoJSON to your computer, and then you can download buildings, any point data, city, boundary, anything available in the OpenStreetMap data. You can download it directly, just 1 line of code. for example, water, lakes, anything. Besides loading data from downloading data from OpenStreetMap, you can also read data from a PostGIS database. So for those of you who have using Geo database or PostGIS database, you can also load the data directly to the map. Just a couple lines code. You can query the data, you can load the data, you can customize how your data going to look like on the map. And you can create split panel map. This can be useful if you want to visualize the changes, for example, before and after certain events or land use, land cover change, or natural disaster. And for example, in this case, land use, land cover, right? So very easy to do. One line of code, you can create something like this. And besides the split panel map, you can also create the so-called link maps, right? So 2 by 2, or one row, 2 columns, as many rows, as many columns as you want. You can create this kind of things easily using Leafmap. Besides those split panel map, you can also use the time slider. So if you're looking at time series satellite data, so in this case, it's the planning imagery, monthly planning imagery, right? So you can use the time slider. Again, no coding. So just click the one button and then you can navigate to any location around the globe. And then you can visualize things like this to see the changes, just like a time lapse, satellite time lapse. And lastly, I think this might be the last one. They can use the white box to do geospatial analysis. So white box tools is a program developed by Dr. John Lindsay, a professor in Canada. And then I built on top of the white box tools to create a user interface. And basically you can directly perform geospatial analysis directly within the map without having to write any line of code. So you can click a button and then you can just select what data and then input, output, then just run the analysis directly within here. And very convenient. Think about if you're using ArcGIS or QGIS, you might have to install a huge package on your computer. And also ArcGIS is not open source. So this one here, everything is open source. You can look at the source code if you want. And this toolbox has 480 tools. So you can look at the source code, you can run any tool you like, and you can deploy the program on any cloud computing platforms, and you can run geospatial analysis. So it's really, really powerful. We'll get into that later, but just to give you some idea what kind of things you can do. Analysis, you can also do visualization. A lot of things you can do using Leafmap. So next, I'm going to show you some demo about the interactive web app that's built upon Leafmap and also Gmap. So today we only cover Leafmap, but I also have the other package called Gmap. And I sent the link in the chat earlier. You can go back to click the link, streamlib.gshub.org. And once it's open, this is what the app looks like, right? So this is the interface. And so you can create, for example, a satellite time lapse or any on the left side here, you can click the menu. For example, I can create time lapse if you want, right? So in this case, I can create time lapse location for any location you like. So you can select, for example, right now I have Landsat, Sentinel, Ghost dataset, and also MODIS, but I will add more datasets. So eventually you can create this kind of animation for any satellite imagery if you want. But this one is built on top of both Gmap and Leafmap. So for example, if I want a specific location, so I can show you here, you can select from the examples, right? If you want. So I can click any of those if you want to, but you're also welcome to select a rectangle somewhere. So let me select here, just show you how it works. So I'm doing to here, pull, right? And then I can simply draw a rectangle somewhere, right? And you can export. You can export this one to your computer, and then you need to upload it back to the app. So I just click upload. Then it's going to be the same, and you can select, for example, what kind of bank combination you want. You can change the title. You can customize the time lapse, how fast you want the time lapse to be, and you can customize the year, the month, everything, or you can just accept the default. And then it's going to just take you a couple of seconds, maybe 20-30 seconds. Then you should be able to create the time lapse easily. And It might take some time, but it will be here eventually, and then you can just download the animation to your computer. So a lot of fun. You can change to other data set, for example, other satellites. So right now I have Sentinel, Landsat Sentinel, right? You see 20, 30 seconds. Now you have this kind of animation easily. You can change the title, you can change the color combination. So it's up to you what you want to do. It doesn't matter what location you want. You can navigate to any location you like. You should be able to create something like this. You can try, for example, they say ghost data set. This is more like for Whaler satellite. And they say, I want to try out somewhere, right? There's a bomb cyclone, and I can just simply click submit. And this is just using a sample area, but you can upload, you can draw any rectangle you like, and then you should be able to create something similarly. But the ghost data set, this one is mostly for North America. So if you're in other regions, you might not have data for that, but you can try it out. Landsat Sentinel, Modis, and others, right? So like this, right? This is a bomb cyclone in just, I think, October in the US. So you can create something like this easily. You can do animation, for example, Modis, right? If you're looking at NDVI, I can do that. For example, if I'm interested in Africa or any other country, I can just, for example, Africa. And you can also create overlay on the administrative boundary on the time lapse. So for example, I want to show the country boundary on the map, on the time lapse, and I can also change the color if I want. I can change to maybe red color. I can change the width. And after that, just simply click submit. Then you should be able to create the time lapse easily. So again, everything is at the global scale. So you can draw a rectangle at the global scale or zoom to any location. And probably take you maybe 10, 20 seconds. Then you should be able to create time lapse. And right now we have 4, but very soon you'll be able to use that for any Google Earth Engine image collection. So, and then you can maximize, take a look, right click, save image as, and then you can download this one to your computer. And you can put it on your website or social media, wherever you want to share the stuff. Okay, so this is mostly built on top of GMap, and try it out. If you can also look at the animation here, if you want to look at how to use that. So on the left side, there's also another one that might be interesting to some of you. So this one is using the US housing data, basically utilizing the data published by realtor.com. So you can have access to the housing price in the US, for example, by county level, by state level, metro level, and there are a bunch of variable available. For example, this is median listing price, right? And in the US, you can see, like, you can hover your mouse, you'll be able to see the median listing price in the US, but this is only 2D. So I can just simply click the button to change it to 3D. So in that case, it'll be much easier to visualize using 3D, right? And then you can press Control on your keyboard and then move your mouse. And this is like 3D. So again, no coding, everything is like interactive, and you can zoom in, you can zoom out, right? Look at how crazy is the housing market in the West Coast, in the Southeast, in Florida, and New York City. And if you like, you can change the color. So on the left side here, there are like hundreds of colors you can choose from, and just one click, you will be able to just change the color. So whatever color you want, you can also maximize the map if you want. It might take a couple seconds. Everything is behind the scene using Python, so it execute in real time. And if you want, I can maximize the map, right? And then you can navigate through, you can turn around. So this is at the county level. You can also do, for example, state level. So if you just want to look at which state has the highest median listing price, of course, you'll be probably California in here, median listing price 726,000. So this is by, you can do it by month. You can also do it by weekly. There are lots of data you can play with. So for example, I can also do, you can change to active listing count, for example, which state has the most active listing count. If it is the 3D effect is not too obvious, you can change the elevation scale to just move it around. And you might need to adjust to a smaller number so that you can, the 3D sometimes might be too much. Right. So just play with the app and maybe you will find it interesting. And there are a lot of things you can customize, color, everything. You can also show the original data. If you just want to see, for example, what the data look like, you can select data. You can, for example, median listing price. It's going to show you, for example, column by state, by county, whatever. You can just also preview all the color palettes. So for example, you can pick up the base color you want to represent the data or the map. And yeah, this one might take a while, but it will show up eventually. And there are a lot more here on the app. You can just click the menu and you can navigate. You can see if you like it. If you're interested in contributing to the project, you can also look at the source code on GitHub. So these are all the, for example, the color palettes. You can just select one of those and then to change the color of the map without coding. So everything is interactive. You can click the link to go to the repository to look at the source code if you want. All right, so that's about the web app. And you can also look at the video. I record some simple demo that you can go through and follow if you want. Okay, so next. Oh, this is about, you can also add, for example, web map services. If you find any WMS services on the internet, you can just use the app, paste the URL, and then you'll be able to load the data. So in that way, you can utilize the web app services without having to install any desktop software on your computer. Interactive, and you can change the color, you can add the legend easily, right? So directly within the user interface without having to download anything. And what else? So that's all about Leafmap and the web app. If you want to learn more, you're welcome to check out my YouTube channel. So I publish a lot of video, I think since the pandemic. So roughly 1.5 years, I have published 325 videos. Average length, every video on average 13 minutes, and total about 3 days and 2 hours. So roughly 75 hours. And so there are a lot of content there. You're welcome to check out and subscribe to my channel if you want to get the latest update about some of the new tutorial or things I'm working on. And if you have any questions, you can leave a comments in the video, or you can visit my GitHub. So I also have some other open source courses. This one is called Geographic Software Design. It's a course that I taught here at the University of Tennessee last semester, and I made all the source, all the video public. You're welcome to check it out. So in this course, I taught how to develop open source packages like Gmap and Leafmap. Taught all the practical skills you need to know to develop open source package. I also have the other one, spatial data management with Google's engine, some introductory level, how to use Google's engine in cloud computing, and also Leafmap. The last one is about PostGIS. So if you're interested in doing database, you can also check out the video. And all right, so it's almost half an hour. And next, we're going to get into some hands-on exercise. You can click the link, or you find the second link in the chat to go to the source code, and then you should be able to follow through. So I'm just going to click. It will pop up here, and it will take you to the Leafmap website. So from here, I'm not sure why there's a line here. Did I just draw something? Is there 1 second? Is there something from the Zoom software? Let me see here.
Sure, Dr. Wu. I'm trying to...
Dr. Wu, if you go to the annotate function, so if you go to the view options on the share screen, and then there's the annotate, and you can, so someone's drawing on the screen right now. So you can delete the annotate, and then you can also
one second, let me, okay, annotate. And let me see here. Ooh. Yeah, the button is not functioning. Draw something. Yeah, when I click, it goes away.
But there isn't
Okay.
a trash
And
can, there isn't a clear.
Okay, it's good
Okay,
now.
great.
Thank you.
Great. Okay, yeah.
All right, so this is a novel example we're going to go through here today, and you can click the link. So first, let's go through the website here. So this is the homepage. You can go to the homepage, and then on the left side here, workshops. So click the third one, YouthMappers 2021, and this is a novel example we're going to use. On the right here, you can see the menu, the table of contents. But let's quickly go over the website, Leafmap, right? You can come here, you can read through if you have time to get an overview, an idea about what Leafmap is. You can also install this one on a computer. So if you want to try it out on your computer, we need to have some basic knowledge about Python and how to install a package. And I also have video, so you can actually watch my YouTube video if you want. You can show you how to get started, right? So scroll down here, you will see some of the examples, how to get started, some of the code examples, and how to create interactive map using different protein backends. And here on the right here shows you a tons of examples. So all the maps here are interactive, so you can actually play with the map. So for example, you can draw a rectangle somewhere and you can change it. You can turn the layer on and off if you want, right? So for example, right, so everything is interactive. On the left side here, interactive map. So this one is using Kepler GL, is the 3D mapping. So if you want, you can also do this here directly on the map, right? So you can zoom in, you can zoom out, you can rotate. You can also change the color. So you can directly change the symbology, for example, on the map. I can change it here, right? Everything is responsive. So try it out. And what else? So the next one here, I'm going to show you here is the API reference. So API reference is basically all the functions and documentation for the package. For example, I can click Leafmap, right? And on the right here shows you all the functions available for the package. Probably there are hundreds of functions available. So you can click any function you like. And then from here, you can click this one to look at the source code. So everything is open source. If you want to learn more about how the package was developed, you can look at the source code. You're welcome to contribute if you want to, right? Every source code, every function, you can click and take a look. So this is about API reference. The second one is workshops. So I've given some other workshops before, and you can take a look at some of the novel example. And so today's workshop basically is a compilation of most of the features that I introduced for the package. So we have each individual notebook. So you can just, for example, click the link. And most of the notebook has 2 tabs. So you can click to open in Google Colab, or you can open in Binder. So either one should work just fine. And you just need basically a browser, and then you can execute source code interactively. We get into that shortly, but just let you know, you can always come back to the website if you want to learn more. And upper right corner here, there's an icon, GitHub. So you can click the link to go to the GitHub webpage here, and every source code is here. And so if you want, you can look at the source code directly from the package here, and you can see some of the things in here. So after this workshop, if you have any questions regarding Leafmap, you're welcome to come to this page and then click discussions. So discussions is where the community asks questions. So you can see from here, I answer questions pretty much every day. So you can go through here. You can search if somebody has asked a similar question or not. If not, then you can create a new one, and then I will answer the questions when I have time. So you can also submit a feature request. For example, if you want to see any features to be implemented in Leafmap, you're welcome to create a new issue. So this is the best way to ask questions about the package. If it's just send me email, sometimes I get too many emails, so it might not get response. But if you put something on there, it's always going to be there. So I will answer the questions as soon as possible. All right, so I think that's pretty much about the package. So next, let's get into the notebook example. So once you are here on this page, you can either click on the icon open in Colab or launch in Binder. So if you if you want to set it up on your local computer, I will show you how to do that if you want. So right now, if you're using Google Colab, it should open instantly. But if you're open using Binder, it might take some time, sometimes 2 to 3 minutes. So it takes a while. But the good thing about this is that it's going to open Jupyter Lab. So it's you have access to the full interactive functionality. For Google Colab, some of the functions are not available in Google Colab. So just want to you to be aware. But once you open Google Colab, you can click the left side here. This is the table of contents. So you can just navigate through if you want. And the lower left icon here, this is to where you can connect to your Google Drive. So you need to sign in to your Gmail account. And then on the left side here, you can actually click if you want. So, and if you want to execute a source code, you need to sign in. So you can quickly go through the example here. I also provide some of the links. So this is the Google Colab. If you have not used that, it's pretty simple and easy to use. It's just an online editor environment allow you to write source code and execute Python source code. And you don't need to install anything on your computer. It just run within the browser. Just think about Google document you use to write report, write anything. You can use Google Colab to write code and execute. That's it. And as long as you know how to click the button, and you are good to go. So there's not much we need to really to worry about. There are definitely some shortcuts to make your coding more efficient if you want to. So Shift Enter, Control Enter, Alt Enter, and I'm going to show you some examples later. But for now, make sure that you can open this one in Google Colab, and then we can continue. So if you're running in Google Colab, you need to I haven't signed into my account, but you can just run through. So right now, just run this one, run this one, run this one, run this 4. This one here is basically to install all the required packages we need for this notebook. So you can download, you can install this one. It's might going to take you a while. I'm gonna take you a couple seconds. So just wait until you see a green check mark on the left, then you are good to go. So again, I'm going to wait for maybe a minute or two, allow you to install. So just click this, the run button, click these 4 buttons. And so when going through the workshop, I'm going to use the one on my local computer. So I'm using Jupyter Lab. Similarly, if you're familiar with Jupyter Lab, it's kind of similar to Google Colab, but it provides more flexibility. Google Colab does not support IPyLeaflet. You just add this support for IPyLeaflet, I think maybe a month ago. So some of the things are not working very well at the moment, but hopefully in the future you can have access to the full functionality of Leafmap. All right, and let me see here. So if you if you finish the installation, executing the first 4 code blocks, maybe you can have a thumbs up as a reaction on there if you want to. And I just to make sure that everyone can follow through. And let me here open the participants.
Dr. Wu, there was a question in the chat asking for downloading the slides.
Yeah, I provided later.
Okay.
So definitely, yes, everything will be accessible.
Great, thank you.
So if you finish executing these 4 code blocks, hit the thumbs up. So just make sure that the majority of you can follow through. Sign into your account, and then we can go from there. Is the one on computer printed by the or Pengeo? Oh, this one is on my local computer, so it's not in there. Okay, so this one is the Pengeo Binder. You can see it's open, so you can see the URL from here, and it might take a while. If too many people are accessing this one at the same time, you might get a timeout error. But once it's open, then you will be able to see exactly the same, just like running on my local computer. So this one is running the Jupyter Notebook on my computer. This one is Jupyter Notebook, Jupyter Lab on the web. So again, as long as you can open it, you should be able to run through the source code. All right, and once you finish that, then So if you're on your local computer, you don't need to run this. I can open it and then restart my kernel. So this one here is the Jupyter environment. So Jupyter environment, basically you can write text, you can write, you can insert images, you can insert videos, you can also write code. So basically it has two components. Let me quickly go back to here. If you double click on one of those, it's going to get into the editor mode. So this is what's behind the scene. And then when you click one, it's going to render something like this. So this is called Markdown. So if you want to learn more, you just can just do a quick search. You will be able to learn that from the internet. I also have a video on YouTube showing you how to use that, but it's not the focus of today. You don't actually have to know how to write Markdown, but you need to learn how to execute the code. So this is a code block. So from here, when you select any of those code block using your mouse, upper right here, it's going to show you, for example, this one is code. If I select the other one, it's going to show you as Markdown. So Markdown basically just text and others, but a code block is where you can write Python code and execute. Okay, so if you're in Google Colab, you need to execute this for. You can also open in Biter, right? Either one should work. Just this one takes a couple minutes to open up, so just be patient. If you want to set it up on your local computer, you're welcome to use Anaconda or Miniconda. So these two are basically a package management that you can install multiple versions of Pythons on your local computer. Think about like if you're trying to install ArcGIS, you can only install one version of ArcGIS, ArcMap on your computer. But Miniconda basically is a virtual environment, allow you to create as many environments as you want for software testing, for all kind of things. And it's very convenient. So these are all the command lines you can use to create. Again, you can always go back to my slides to the video, how to install the package. Let me show you in here. So I have a YouTube video showing you how to install, and because it's going to take time to download and install everything. So I'm just going to use the environment that's already set up. You're welcome to use Google Colab, so should not be an issue. All right, so once you have installed the packages, set up the environment, then you can go to this section here, 0.31, to create interactive map. So right now, Leafmap has 5 protein backends. So basically, you can select any of those, and then you'll be able to create an interactive map just using one line of code. So let me execute this one. You can hover your mouse on this code block, and then click upper right here, run this selected cell, or you can use a shortcut, Shift Enter or Control Enter. So Shift Enter is going to execute this code and then to create a map just like this. So try it out, see if you can see this map. And once it is created, you will see here upper right, you will be able to see the toolbar, and I can dock the toolbar. I can also turn the layer on and off. You can change the opacity, something like this. Right. And so later we're gonna get into how to use some of those interactive. So this is basically a toolbar. You will get longer and longer in the future. Right now, this is what the features, some of the features that I have implemented. But there are a lot more things you can do with Leafmap. So this is the default one using so-called IPyLeaflet. Let me give you an analysis. Basically, right now I'm asking you to write a report, and you can choose Google document, you can choose Microsoft Office, you can choose Microsoft 365, or you can use Mac, whatever text editor you want to use, right? So in this case, I'm using this one called IPyLeaflet. It's a mapping library built on top of Leaflet. So this is the default one that provides the most interactive functionality for the package. You can also use the second one called Folium. So Folium is another library. And again, just pay attention to what we are doing here, import Leafmap. So this one here is import Folium map as Leafmap, and then everything else remain the same. So basically, you just need to change one line of code, then you can create the map using different protein backend. They might look very similar because it's all using the OpenStreetMap as the base map, but you can customize easily. So this is the Folium. On the left side here is the toolbar. it looks slightly different, right? So this one is IPy leaflet, and this one is Folium. For Folium, you won't be able to see the toolbar because the toolbar is only available in IPy leaflet. So you should always use IPy leaflet unless it's really necessary. So okay, and then you can also use Kepler.gl. So this is like 3D. Again, this is just a simple base map here, and you can zoom in, you can zoom out. Last one here is using PyTex. Again, import Leafmap.tech and then use PyTex. So they look slightly different, but behind the scene is just create a base map. And PyTex and Kepler.gl, you can create 3D. So I'm going to show you more examples later. All right, so the first step is creating a base map, right? And hopefully you'll be able to create something. And next, I'm going to show you how to customize, right? By default, it's center around the US, but you can easily customize the center to any location you like using the latitude and longitude. So I'm going to do it the same here. Import Leafmap. So when I rerun this one again, it's going to again import the IPy Leafmap protein backend. So I'm going to just run this one here, right? And the center, this is latitude 40 degree north and negative 100 degree west. And the zoom level is how, like the larger the number, the more detail you'll be able to see on the map. So I can change this one to another location, for example, 51.5 and negative 0.5. So as long as the latitude within 90 degree and longitude between negative 180 to 180. So you'll be able to create a map center at a certain location. So in this case, it's centered around London. So you can change the zoom level. The smaller, the less detail you're going to see, a big overview, but the larger the number, for example, 17, 18, is going to zoom to the highest level, right? And you can zoom in, you can zoom out. So this is how you can customize the default location. If you want to change the size, for example, how big is your map? For example, the height and the width, you can define, change the pixel, for example, 400 pixel height and 800 pixel width, right? So then in this way, it's much smaller. So sometimes you want to take a screenshot or something, you want a smaller one, and this allow you to customize that. Besides customize the size, you can also set the so-called control visibility, right? You have a lot of toolbars here on the left. You also have a toolbar here on the right, and it might be too crowded. So if your map is pretty small, you can turn those controls off. So just like this, when you create a map, you can specify, okay, I don't want the draw control. I don't want the measurement control, full screen control. You can turn those things off if you want, right? So right now it's just a simple base map with the zoom control and also the toolbar control. If you want to remove all of them, you just simply use clear control. So again, for those of you who are new to Python, basically you can create an object and then create an object and then assign to a variable, and then you can use a lot of functions or properties associated with the object. So Python is an object-oriented language, so you can easily use this to do a lot of things, basically do a lot of operations directly on the object. So in this case, we create an interactive map using the IPy leaflet protein backend, and then we clear all the controls, right? So if you can also use a control / on your keyboard to comment out a specific line of code if you don't want that. And for example, in this one, once I comment it out, if I execute, this would be the default IPy leaflet map, right? So if I execute this one, I don't have to execute directly in the same code block. I can come back to here, and then I can press B on my keyboard to create a new one, and then I can paste my line here, right? So pay attention. The IPy leaflet is like bi-directional communication. So even after I create a map, I can modify the map later, and it's going to change the map above. So pay attention here, right? We have all the toolbars. If I run this one, it's going to create the output, right? So it's Very nice. If you're using Folium, you cannot do that. So once the map is created, you are done. You cannot modify the map. So IPyLeaflet is very flexible and powerful. So you should use this one by default, unless you really something doesn't work with IPyLeaflet. All right. So this is how you can create a map and then change the size, change the location, if you want. So next, let's talk about how to change the base map, right? So by default, is using the OpenStreetMap. You can change to Google Map. You can change to any other base map you like. So again, I'm going to import the library. You will see here, I import Leafmap all the time. If you're just on one notebook, you don't actually have to do that. The reason I put this is just to make this example easily reproducible. So you just need to copy the lines of code in here and then put into a new notebook. It will work out of the box. But sometimes if you don't import the library, it won't work. So and I'm going to create a map. So in this time, I'm going to use Google, the terrain base map is the base map, right? So you can pass in the argument Google map equal to terrain, and then you're going to use the terrain base map. If you want to use, for example, a satellite, I can just simply copy, paste, shift enter, then you have the satellite base map, right? You can also use a hybrid. So hybrid is the one that you can have the label. Looks like I have a typo here. Control C, Control B. It should be BRID. Sorry about it. All right, now you see the labels in here. And again, very easy to do. One line of code. You can have the base map. You can have a full screen if you want. Right, click this one back. Right. Besides adding the base map directly when you create the map, you can also add the base map after the map is created, right? So for this line here, first line, create a map, and then the second line, add base map. Okay, so this time I'm adding Esri base map, right? Shift enter. Then you have this, right? So you can zoom in, you can zoom out. Again, you can go to the toolbar here, upper right corner, and then you can click the layer control, and you can turn the layer on and off. You can change the opacity. You can also turn all the layer on and off at the same time. So this is basically a toolbar I built on top of an IPy widget. This one is only available for IPyLeaflet. If you use Folium or Capital GL or PyDeck, you won't be able to see this one. Okay, and again, there are a lot of base map available. If you want to see all the base map, you can run this one directly. It's going to show you the list of all the base map, right? Hundreds of base maps are available, and all you need to do is just simply, you can just simply copy. You can just select, and then Control C, and you can come back to here, paste, shift enter. Right, now you have the new base map. So this is how you can add the base map using the coding, but you don't have to. You can actually create a base map. You can change the base map interactively, right? Again, I create the base map, create the interactive map. Then I can click upper right corner here, the first icon. So this is where you can change base map. So I can click the icon. Then you can select from the drop down list, right? The hundreds base map available here. They say I want the satellite base map. I want the terrain base map, or I want the NLCD, National Land Cover Database, or any base map you like. For example, Esri, National Geographic, right? Or what else? Open Topo Map, for example. Right. So can you change that easy without having to write any line of code? As long as you can create the interactive map, you can do that. So this is the first one. You can change the base map. You can also click this icon here, or the search icon. So if you click this one, and from here you can search any open accessible web map services. So I can just type, for example, open, right? Just hit enter, and then you will be able to select from the drop down list, and you can easily add those to the map. For example, right, open snow map. I'm not sure if it's available or not, but some of those you might need to have the API key, but most of those should be available directly. For example, hot, right? So you can change it easily. If there's nothing is available there, you can also click this icon, check the box, search quick map services. So this one has thousands of base map. And for example, if you want to try to add Google Map, I can just type Google and then hit enter. So scroll down with tons of base map. So I can add, for example, Google Map, Google Satellite, Google Terrain. I just hit enter. It's going to take a couple seconds and then you have the map, right? So you can, if you already know the name to the base map, you can add the name. If you don't know it, you just come here to search and then you'll be able to add it, right? So you can add as many base map as you want. Right now we have a couple rows in here: Google Satellite, Open Topo Map, OpenStreetMap, right? And you can turn it on and off, depending on which one you want to use. All right, so this is how you can change the base map. You can also add others. For example, if you hosted some web services or if you know some other URL to load our web services, you can directly use the function add tile layer and then to add to the map. So if you're just beginners, yeah, most likely you probably don't need this, but just let you know, you can customize. For example, this is the URL to the Google Satellite database map. You can just add the URL, one line of code, they can bring in the data to the map easily. You can also bring in, for example, WMS or others. There are lots of base map directly available. Looks like the notebook is here on the left side. Okay, so next one here, I'm gonna show you some more like interesting one is to add some vector data. So again, we create an interactive map. Assume that you find some vector data or geospatial data on the internet, hosted somewhere, then you can directly load the data to the map. So in this case, we're going to add a GeoJSON, right? So in GeoJSON, and then just passing the URL, and then boom, you will have the map directly, right? So just a couple seconds. Now we have this map. So the data is hosted on GitHub. So if you want, you can copy the link and then open a new tab. You'll be able to see what the data look like. So this is basically a GeoJSON format, and you can find a lot of those sample data on the internet. And as long as you have the URL, you can pass in the URL, replace this one, and then you can give a layer name. So the layer name is where it's going to show up here on the layer, right? Oh, OpenStreetMap cable. Oh, it doesn't show up in here. So you can have the layers control if you want to use the layer control over there. And info mode on hover, basically when I hover my mouse on the data layer, lower right corner here is going to show you the attribute associated with the feature. So if you want, you can hover a mouse, you can zoom in and zoom out. So this one is all the cable between ocean cables, basically all the communication, all the internet access across continents. These are all the data where they are from and where the origin and destination. So you can check out this in here. By the way, so you see this one here, the format looks like a bit weird. It looks normal in Jupyter Notebook, but in Jupyter Lab looks like there's an extra space. So this is probably a bug of Jupyter Lab. Besides adding color by the data by default is black color, but you can also have a random color. For example, in this case, I can add a country GeoJSON, right? So this is a GeoJSON represent all the country boundary. And again, if you have the URL, then I just m.x GeoJSON layer name, and then the field color, basically the random field color. I want to randomly fill the polygon with red, yellow, green, and orange. And then you'll be able to, for example, when you hover your mouse, then you can select on the right here, you see this one. You can minimize if you want. So if I click this one, it's going to minimize. If I click this one, it's going to pop up, right? This can be easily customized. So for example, I'm going to change the color to cyan, and maybe have another one, maybe pink, whatever. You can easily customize, right? So now you see the color will be changed because it's assigned randomly. So you're welcome to check this one out and test it with some other data sets. You can also use all kind of other random color. So we don't have time to go into every detail, but you're welcome to check out. So for example, you can also add shape file, for example, right? You can one line of code. You can, if a shape file is contained within a zip file, then you just add the zip file and directly you'll be able to have the data, right? So you can also add KML if you're using KML from Google Earth. You can also load the KML directly to the map easily. So this is how you can load the vector data. If you're familiar with GeoPandas, GeoPandas is a very powerful package for dealing with vector data. So again, the same data set, but right now we read the data using GeoPandas and then add the GeoPandas to the map easily, right? And you can also, for example, add the point layer. This one I showed you earlier in some of the examples, like when I create a map and I can simply, for example, here, if you have some data on your local computer, right? I create a map and then I can click the open icon. So from here, I can select any data set. For example, I have a CSV on your computer, and then I can actually open the data. You can navigate through that. If you have some data already on your computer, you can directly open using the CSV. Or let me show you here. If you have this, for example, I have this GeoJSON somewhere, right? Let's say you download a GeoJSON from the internet to your computer, and then you want to load this one to the map, you can do that as well. So I'm just going to maybe select this one and then examples, workshops. So let's say I download this one to my local computer, and now I have the file. So I can come back to here again, open CSV, select. I'm not sure why it's not showing up here. Let me recreate a map. Sometimes you might need to recreate. Okay, open CSV. Interesting. Anyway, so if you can navigate to a directory, you can open it. Otherwise, you can also act directly using source code. So here, I can create. Oh, it's a GeoJSON. Yeah, good point. So let me see here. It's not a CSV. So I'm not sure. I don't have a CSV here, so that's why it doesn't show up. But you can add a GeoJSON directly to the map if you want. So this is a GeoJSON, right? This is a marker cluster for all the cities in the US, right? So you can zoom in, you can zoom out, and just a couple lines code, you can create this kind of an interactive map easily. So there's a pop-up attribute, for example, name and population maximum, right? So you can click the map, right? Again, you can open if you have the CSV on a computer, you can open as a CSV if you want. And lastly, you can add any vector data set. So it can be GeoJSON, and can be shapefile, it can be anything GeoPandas supported. You can just one line of code, use a m.x vector, and then you can load it to the map easily. So this is how you can open vector data in Leafmap. Besides opening data, sometimes you might want to download some data. So as I mentioned earlier, OpenStreetMap is a huge vector database. You can download any vector data from OpenStreetMap using Leafmap, just one line of code. So here I create a map and then I use m.osm from geocode. For example, I want the boundary for New York City. Use just one line of code, then you have this, right? So right here, you can turn the data layer on and off. So this is different from the base map, right? So the base map here is just the base map. You don't get access to the original data, but now we can actually download the data to our computer, and then you can use for some additional data analysis. So anything you see on OpenStreetMap here, you can download it. Either it's boundary, city, lakes, highway, whatever, you can download the data easily. Just one line of code. So for example, I want to download the data, the boundary for Chicago, right? You can easily, you can have the data, just a couple seconds. Now you have access to the data. So this is a GeoJSON, and then you can convert to shapefile or any other data format if you want. So for example, I want to download buildings. Let me see here. This one is using the API. So build on top of the OSM NX API, and then to download the data. And you see here. Okay, so now we have all the buildings again, right? You can specify a location, a region, and then you can download the data easily, right? So it's building. If you zoom in, you will see the building outline match exactly what's showing up here on OpenStreetMap, because behind the scene is a vector database. You basically just extracting some of the data from the database and then get it to your local computer so that you can use that for additional analysis with your other data for your project. You can also based on the address or based on a bounding box. So for example, you want to download data for all the bars in New York City. We're going to take you a couple seconds. And so here you see a lot of warning. It's normal. So now we have downloaded all the data directly, right? So these are all the points available for the area. You can do that for a bounding box. For example, you can zoom to a specific location, and then you can just one line of code here, add OSM from bounding box. You can specify the north, south, east, west, basically the latitude and longitude, and you can specify what kind of features you want to download, and then there you have it, right? So very easy to do. You can also specify from a specific location, for example, from a center, and then you want to do the buffer, right? So for example, I wanted to download all the lakes at a specific location within the buffer area, right? So for example, here I downloaded some of the lakes in Minnesota, right? So here you can hover your mouse, move around, you'll be able to find those pretty easily. And what else, right? So you can also do this, create a map, right? This is a bounding box, right? The current view. I want to download the data from the map view here, and you can just one line of code, you can do it easily, right? So this is providing a way for you to download any data. Sometimes you might, you can try out Leafmap. If you need to download some vector data, you don't have to go online everywhere to search and download data. Just go to OpenStreetMap and take a look, see if there's data available for your area, and then just use Leafmap to download data and load it to the map pretty easily. And that was the less about loading vector data. And the next one here, I'm going to show you is that you can actually do some geospatial analysis with Leafmap using white box. So let me quickly execute here just to show you what white box looks like. So if you create a map and then using the toolbar here, click the toolbox icon. So this one, once you click, it's going to pull up the toolbox. So let me maximize a little bit, right? At the low right corner here, this is the toolbox. And this is the toolbox. Just think about ArcGIS toolbox or QGIS toolbox, right? You have a bunch of tools that you can run geospatial analysis. But keep in mind, you will have to install a huge package, gigabytes of the package, in order to do that kind of analysis. But right now, you can do that directly using a browser. You don't have to install anything. Of course, you can set it up on your computer, but this one has access to 487 tools, and the tools are open source, so you can click to view the source code. And again, this one was developed by Dr. John Lindsay in Canada, and all the source code are written in Rust, RUSD programming language. And then I built on top of the program to create interactive user interface just like this, so that you can easily use this to do geospatial analysis. You can search any tool, do hydrological analysis, LiDAR tools. There are a bunch of tools available. So try it out, and you might find it much faster than ArcGIS. And everything is open source. If you run into any issues, you're welcome to post questions on GitHub. So next, let me quickly go through one example here. For example, you can also use, if you don't want to use the map interface, you can just directly Leafmap.whitebox GUI. You can also open the interface, user interface. So this is directly here within Jupyter Notebook. And you can also use the other mode. So this one is called treat. Treat mode means, let me restart my kernel. I logged a warning here. And let me come back to here, import Leafmap. And look at this one. So the treat mode basically is the same functionality, but give you a different experience. So now you can use the treat mode to actually to select, for example, here, click the plus sign to expand. You can also source tools. For example, they say, I want to fill depressions of a DM, just search a keyword, and then just hit enter. You should be able to find a tool, for example, fill depressions, and then you can run analysis from here. So you can either do it using the interface, or you can directly use the source code. So in this case, this is example using white box tools to do some hydrological analysis to fill the depression, smooth the DM, fill the depression, and then calculate the flow accumulation, right, for hydrological analysis. So once I have this, you will see it's only taking, the data set is just small, so it's just a couple seconds. Then you have the data. You can also display the data directly on the user, on the notebook, right? So original DM, smooth the DM, and this is called depression breaching. Basically, fill the sinks in the DM, and then you can calculate the flow accumulation. So later on, you can extract the swim network if you want. So you're welcome to try this one out using either source code or or you can directly use the interface. So I can, for example, select data. As long as you have the data, for example, I can select the DM and then select, set the output. For example, I want my output to get a file name. You can say field teeth, and then just click select, right? And then click the run button. You see here, 0.5 seconds, and then you're done. Then you have the data. You can use the data for further analysis if you want to. So there are a bunch of tools in here. Every tool is depends on application. So you can just search, right, either from here or you can search from here. Depression. Right. And try it out. This one is very powerful. So there certainly will be some tool that might be useful for your project. All right, so this is for geospatial analysis. Looks like we have 15 minutes to go, and we won't have time to cover all of those. But next, let me quickly go through some other things you can do. Right, I showed you earlier, you can create a base map gallery. Right, we have hundreds of base map. So if you want to see all the base map all at once, you can use the Leafmap link maps, and you can, like, for example, in this case, I have 100 base maps display here, right? 20 rows, 5 columns, right? 1, 2, 3, 4, 5, and then 20 rows, right? So everything is linked together. If I zoom in to a specific map, it's going to zoom to all the maps, right? And depends on your computer. This one might be a bit laggy. If you, it might be kind of a frozen, but if you see from here, right, pretty nice. And you can scroll down, you can take a look at some of the base map. So this one gives you a quick overview how to pick up a base map that you like. You can also see the label, right? You just need to remember, okay, just copy the label, and then you can use the add base map function that I introduced earlier to create a base map. Okay, so it's a bit slow. I'm going to clear the output and then restart. Okay, so the next one here is actually similar to the base map gallery, but this one allows you to create a link map. Okay, let me show here the second one. Just like this, right? If I zoom in, if I pan one of the map, it's going to show you how to move around the map, right, easily. And you can also do lane cover change, right? Like I show you in the video, right? Zoom in, zoom out. So this one here, have you all the layer, base map layer? You can set up the label, right? The label can show up here, upper right corner, and then if I move around, you'll be able to do that. Okay. So this is the link map. The next one is about the split panel map. So again, if you want to visualize the changes on one single map side by side, you can do it this way, right? So Google Map, satellite map, right? You can zoom in. It's going to show you here. So this is especially helpful if you want to visualize the changes of 2 data layers, right? I can do any other base map layer, this one, and also lane use, lane cover. So for example, NLCD 2001 and NLCD 2019, right? So you can see the changes. This is in Las Vegas, right? So on the lower left corner here, showing you 2001, and the one lower right, 2019. Again, zoom in, zoom out. Pretty easy. So one line of code, basically, you can create a map like this. Besides speed panel map, you can also create a heat map. As I showed you earlier, if you have a CSV file containing the location, latitude, and longitude for some locations, you can use Leafmap to create heat map. So heat map basically is just like cluster. If you have more points at a location, it's going to show up as a cluster. So this is by default. If you zoom in and zoom out, this is just a city. So you see, for example, some of the cities cluster in the coastal area. And this is using the IPyLeaflet plotting backend, but you can also use Folium. I think the Folium looks a little bit better compared to IPyLeaflet. So this is another one using the same data, but you can add a color bar here. You can also add a title. If you want, you can download this one as an HTML, and then you can embed this one to a website if you want to. So very, very flexible.
Dr. Wu?
Yes.
We do have some questions. Do you think we could take just a few moments for those?
Yes.
Okay, perfect. So someone in the chat wanted to know if it's possible to carry out all of this in a Jupyter notebook.
Yes. So this is right now running in a Jupyter Lab or Jupyter Notebook. Either one should work.
Perfect. Okay, great. And then we had another question about installing Leafmap. Do you have any kind of tips for that?
So the Leafmap, if you go to the slides, right? So it's here, all the instructions on how to install. You can install using pip, or you can install using Conda, and also a video here showing you how to install step by step. So you can try it out, see if it works. If you have run into any issues, you can submit questions on Leafmap, and then from here discussion, you should be able to ask questions from there after the workshop.
Okay, great. And then we had another question. Does it support WFS services?
This one right now is not supported yet, but I think I have some other one. I didn't show that here, but Leafmap actually support vector type. So you can go to the notebook example, and there might be a one here, vector type layer, but it doesn't support WFS services. If something that's supported by IPyLeaflet or Folium, I can add it. But if they're not supported, then something is not something I can do at the moment.
Okay, great. And then another question someone wrote, if I have created some rasters, say monthly, 1 year long lightning raster data, can we use Gmap to create an animation from it? And can we upload our rasters?
Yes, so you can upload data to your Google Earth Engine account, and then you'll be able to create animation. So I have a lot of video tutorial on. You can go to gmap.org, and on the left side here, notebooks. I have a bunch of notebooks showing how to create animations. I'm not quite sure which one. For example, add animated text, add color bar to GIF. Just go through loads of videos. I show you how, for example, once you upload your data, then you can prepare your data, and then you can download the animation to your computer, and you can also add text. But in the future, I'm going to make it much easier. So you don't have to write any line of code. You will be able to create animations.
Oh, great. That's wonderful. Yeah, and I'd like to just add, we were actually talking before the session started about possibly doing another session totally focused on Gmap. So keep an eye out for that. Yeah, that'd be great. Okay, and then someone wanted to know, they said, can we connect with different APIs of geolocation?
Yeah, okay, certainly. I think Leafmap also has a function allow you to, for example, get the location of, I'm not sure it's Leafmap or Gmap, there you can get the device location. So basically, when the user, for example, when you deploy this one to the web, when the user open your map, it's going to center around your location. Just like when you open Google Map, it's going to center around you. For example, I can open Google Map. You can actually get your device location. For example, I'm in Knoxville, Tennessee. So you can do something very similar in Leafmap or Gmap. So when you deploy the app, when the user go to your app, it can actually center around the device location if you want to.
Okay, wonderful. And then another question was, can we open NetCDF raster files?
Not right now, not for, but you can use some additional packages. For example, X array. You can try it out for X array. That one can deal with NextDF. You can also use Gmap. So Gmap supports NextDF, but not DiffMap yet. So you can go to gmap.org and then notebooks. If you scroll down to number 68, so it supports converting NextCDF to Google Earth Engine image, and they can use that to do analysis. But this is just a prototype. It's not fully functional. It's just only for small data set. If you have a huge data set, it probably might not work very well, but certainly it's possible.
Mm-hmm. Okay, wonderful. And then one more question from the chat is, how can someone add the icons of location?
So icons location, that one you need to do some coding, but so all the locations you can change the size, you can change the color, you can change the shape. If you want, you can go to IPy leaflet, because Leafmap built on top of IPy leaflet. So anything available in IPy leaflet, you'll be able to use that. So in this case, you can, there's another one here, for example, awesome icon, right? So if you see this one here, you can change the style, right? Not just for marker, you can change this. You can also provide your own icon. And let me see here, what else? Marker cluster hit icon, right? You can change even to something like this. You can move around if you want, right? So it's very flexible. You can customize to any icon as long as you have the point location, and then the icon and the size and location can be easily customized.
Wonderful. That covers all the questions we had so far. We now welcome any participants. If you want to unmute yourself to ask additional questions, we've got about 5 minutes left for that. And I'll just, while you're thinking of those questions, I'll point out, I posted a link to an evaluation form of the session in the chat. Those are really helpful for us as we plan and always work to improve these sessions and learn more about what kind of topics you're interested in. So if you could please complete that form, it will take only about 3 minutes. That would be great as well. Any other questions, we welcome them now. Thanks.
Yeah, so you all can use the notebook. We don't have time to cover all of them, but there are last couple of those that might be very useful. So for example, for the planning imagery, 5-meter resolution at a global scale, monthly and quarterly. So you can use this one to visualize changes. But this one does require a planning account. So you need to sign up for an account and then get an API, and then just replace your API key here. You should be able to use this one, and then you can create, for example, speed panel map, right? You can zoom in, you can zoom out, you can go to any location, look at select a specific month, and you can look at the changes pretty easily. So this is how you can use the so-called time series inspector. But you can also use the time slider. So this one will also be very useful. For example, let me show you in here. All right, so the time slider, you can click the slider, you're going to navigate through, so you can see the changes. And let me go back to this one here. So for example, once I create a map, and then as long as you have the API key, I can go to, I think it's this one here, time slider, right? And so this is a lake, right? I can just let it go through. So from 2016, every month you have one imagery, you can see the changes, right? No coding, you just create a map. As long as you replace your API key here, you should be able to see something like this. So you can do that for any location around the globe without having to write code. You can use that to visualize changes.
Really awesome.
Mhm.
I think if we don't have any more questions, we can start to wrap up. And I just really, really want to thank Dr. Wu again for joining us today. This has been amazing. I think it's opened up our eyes to all of the different possibilities of ways to do interactive mapping and geospatial analysis within Leafmap. And you've clearly built out a great library of tools and resources for the students as well. So to the attendees on the call, please know we'll share this recording and all of the links that Dr. Wu shared throughout the chat. And I hope this is just the start of your journey to learn more about interactive mapping and geospatial analysis.
Yeah, thank you very much for attending. And again, if you have questions, you're welcome to go to the GitHub repository and then can submit questions there. You can submit on Leafmap, or if the question is related to GMap, you can also go to the discussion. So hundreds of questions have been answered. So you're welcome to submit questions from there, or you can leave comments on my YouTube channel or Twitter, whatever you like. Thank you very much. So I hope to see you in the future in another webinar.
Yes, thank you so much. We hope you have everyone have a great rest of your day. And yeah, thanks, Dr. Wu.
Thank you.
Bye.
Take care, everyone.